Hey there, guys. A big warm welcome to today's counting and probability session, proudly brought to you by the Learning Space. If you're joining us for the very first time, my name is Tepankati. Remember that today's session is specially paced and focused for you, our rising stars. Whether you're joining us on Zoom or TikTok, you're in the right space to ask questions. Please take your time and get the support that you need. Remember, before we start, please do not forget to like this session, subscribe or follow the Learning Space, and share it with your classmates because success is better when we all win. Let's break down counting and probability and build your confidence one calculation at a time. Right, I'm going to share my screen and then we are going to get started with today's session. Remember, you are definitely going to need pen and paper and a calculator. There will be questions that I will ask you to attempt by yourselves. If you are struggling with probability, this is definitely the session for you because I will be going as far back as grade 10 revision. All right. So I'm going to share my screen and then we are going to start. Great stuff. Please just give me a thumbs up reaction if you can see the screen that I am sharing. Perfect. So we can all see it. If you cannot see the screen that I'm sharing, maybe try to leave the meeting and come back. It just might be a network issue on your side because I am getting a lot of thumbs up. So it means that the screen is up. All right, perfect. So today's session, you will be taking down a lot of notes because probability does have a few words that are a little bit difficult to sort of comprehend. And I'm going to try and break them down as best as I can for you guys. Remember, if you have questions, you're more than welcome to post them in the Q&A or use the chat functionality to ask your questions. And we will try our level best to attend to most of those questions. If there are a lot of questions, obviously we cannot attend to all of them, but we'll try our level best to try and answer as many as we possibly can in the given time. I see a lot of people are actually quite eager. When are we starting? Usually we will start at around 3 to 4 minutes after 6 o'clock because we are giving people some room to try and log in. Remember that some people are having network issues, so we have to always just allow a minute or two for them to try and fix their issues before we start. Okay. Perfect. Now, the easiest one, right? In grade 10, they introduced probability, right? The probability of an event occurring, right? Now, remember that the probability of a certain event, I'll say PE, is what? Is the number of times we can see that event over the number of times the sample space is big, or the sample space, right? What do I even mean by a sample space? Okay, just a second. There we go. So sample space is just what? The total number of outcomes. That's a sample space. Now, let's make it easy for ourselves. Let's think of a coin toss. How many options or how many outcomes can we observe when we toss a coin? We either have a tails or heads. Okay, now it means that for this coin toss, our sample space is what? Would be 2 outcomes. We cannot have anything more than 2 outcomes. Okay, now here comes a question. They're asking you, how many times can you observe a head on this coin? It's a normal coin. Maybe let's think of a normal 2 rand coin. It has a head and a tails. How many times can you see a head? If you toss it only once, you can see a head once. And what is the sample space? The sample space is 2. Are we together? Now let's think of rolling a 6-sided die. Okay, so the dice is plural. That's when you have 2 of them. But if it's 1, it's just die. So if I'm saying die, please do not be confused. It's just one of those things. Now, for this particular die, it's six-sided and it's a fair die, meaning that it has the options 1, 2, 3, 4, 5, and 6. Okay, now how many times can you see an even number? We roll it, right? What is the probability of getting an even number? The probability of getting an even number would be 3 out of the total, which is 6. Okay, that's the basics of probability. Okay, now this is not that necessary. I just needed to at least explain it using some words there and some visuals so that it makes sense to everyone. Now, let's talk about theoretical and experimental probability. Just give me a second. And experimental. Now, consider the very same situation that we just spoke about of tossing a fair coin, right? So in theory, obtaining a head is 50%, right? Why is it 50%? So in theory, let me just write the coin toss. In theory, observing a heads or a tails, doesn't matter, any one of them. So observing a heads is 50%. That's theoretically, right? But now when we say experimentally, right, remember that when you do it experimentally, you have to do it a number of times, right? So it doesn't mean that you are always going to get heads to be 50%. So for experiments, maybe you're going to toss this coin 10 times. When you toss this coin 10 times, it doesn't automatically mean that you're going to get 5 heads and 5 tails. That's not what it means. Right? For you to be able to get that number to approach 50%, you need to toss the coin a number of times. And that is experimental probability. Okay, just so that you know the difference between the two. Okay. Now, if you're taking notes, please do take a screenshot, but some of these are earlier grade revision. That's why I am erasing them, but do take a screenshot quickly so that we can now look at notation, the addition rule, complementary events, mutually exclusive events, and the likes of. Okay, 10 seconds to take a screenshot, and then we move on. 10, 9, 5, and go. Cool stuff. Now let's look at the notation. Right. I am somebody who struggled a lot with notation because I'm seeing a lot of symbols that I'm not used to, or symbols that I was not used to then. I was used to division, multiplication, derivatives, and all of those. Now, when we say the probability of A or B, mathematically, how we represent that is we will say this is P, A, this is O. Okay, now when we say probability of A and B, so P, A, and B, right? Now, how I remember them, okay, let me just do this, and right, this is a lowercase n. This is the letter N, lowercase, right? In lowercase. Now, because it's lowercase n, I then automatically remember that n sort of rhymes with and, because there is an n in between and. Then I never ever mess up the two. Right. Now, this one is called a union. And this one is called an intersection. All right. Now, there is another one. The probability of A given that B has occurred. I'm going to write it in full for you guys there. That's what the symbol stands for. Are we all together there? But what does this even mean? Now, what is the probability of it being cold given that it was snowing yesterday? That's what it means. Given that B has occurred, what is B occurring? B is snowing, and then A is it being cold. What are the chances that it's going to be cold given that yesterday it was snowing? I'm hoping it makes sense to everyone. Okay, maybe actually let me scroll up because I want to include these notes when I give them to you guys. I don't want to erase anything. Now let's look at mutually exclusive events. What do we even mean by mutually exclusive events? It's a lot of confusing terms. Okay, so there is another question. Please example for A, given that B has occurred. Okay. Now, let's think of it this way. At the moment, schools are closed, right? Now, given that a school is closed, given that schools are closed, let's go back here. Given that schools are closed, that will be B. Now, A, learners writing a test. Those are two conditions. What are the chances? Then I can pose this question. What are the chances of learners writing a test? So if I say the probability of A given B, this simply means what are the chances of learners writing a test given that schools are closed? I'm hoping it makes sense, Trevor. So B has to occur first, and then we look at A. So I repeat, given that schools are closed, what are the chances of learners writing a test? I'm hoping it's clear to everyone now. Okay. All right. You guys are taking me back. Maybe I need to do that explanation so that we're all on the same page. So union, right? Remember what I said? I said this is O. So let's take it to school. A learner does what? Either English home language, or maybe they do Tswana home language, or whatever their home language is. Right. Now, and is an intersection, right? The chances of a learner doing what? Both maths and maths literacy. So you'll find that there are some odd cases where you have learners doing math and math lit. Sometimes they do allow them to take up both math and math lit, especially the IEB guys. Right, so you'll find a few of them here. That's the intersection. They can happen at the same time. Okay, now taking it back to a coin toss. This is what's happening. So with a coin, remember that you cannot have heads and tails happening at the same time. So you either have a heads here and a tails there. You either have a heads or you have a tails. Now, you cannot have a heads and a tails at the same time because they do not intersect. But let's think of something. We roll a die and we toss a coin at the same time. We want to get a heads on the coin and we want to get an even number on the die. So this can be represented as the probability of what? A heads and a what? And an even number. You toss that coin, you get a heads. You roll a die, you get either 2, 4, or 6. Those are happening together at the same time. That's when you use AND. Okay, perfect. And I also explained the conditional probability, the probability that learners are going to write tests given that schools are closed. Those chances are slim to none. Okay, perfect. Now we're talking about a mutually exclusive event. What do we even mean when we say events are mutually exclusive? We simply mean what? They cannot happen at the same time. An easy example could be what? Could be getting both a heads and a tails, tossing one coin once. It's going to land on one side. It's a fair coin. It definitely has to land. I'm hoping it's clear for mutually exclusive events. Okay, using a die, we roll a die, and then let's say event A is what? Is obtaining maybe a 5. And then event B is what? Is obtaining a 2. You're still rolling it once. Now, is it possible for you to get a 5 and a 2 when you roll this die once? No, it's not. Right? Because it's not possible for you to obtain both a 5 and a 2, we can then say the probability of A and B is equal to 0. They cannot happen at the same time. Is it clear for everyone? Make sure that you wrote this down. These are mutually exclusive. Okay, now let's talk about the addition rule. Now the addition rule states that the probability of A or B is given by this. The probability of A plus the probability of B minus the probability of what? Of A and B. Okay, we're going to do an example just now. This is just a formula. You don't have to memorize it. It is given on the formula sheet. Then you have to remember something. We just spoke about what? About mutually exclusive events. If a note, if then what can we say about this? Anyone? If you have an idea of what we can say about A and B, given that A and B are mutually exclusive events, what can we say about them? Perfect, Lysanda. Thank you so much for your answer. Thank you so much for the answers that are coming in the chat. See, you guys are with me. We can then say that this gives us 0. This means that our equation, P of A or B, is simply going to be what? The probability of A plus the probability of B. And that's how it works. I'm hoping you guys can see the light now. Great stuff. I'm getting a thumbs up. Cool. Now remember that on your formula sheet, they will just write it this way. Probability of A or B is equal to P of A plus P of B minus P, A, and B. These are the symbols that you need to be aware of. We've discussed them. I think everyone is happy with that. Okay. Now, complementary events. Right. Be careful of this E. It's not an I. They complete each other. They're complementary, not a complement. How do we even describe complementary events? Now, complementary events, I always want to start here, that the probability of event A plus the probability of event B must give you 1. I'm hoping it's clear for everyone. That's how I start describing complementary events. An easy example is a coin toss. That's where everything begins. Right? A is what? Heads. B is tails. What is the probability of getting a hit if you toss a coin once? It's going to give you 0.5. If you toss the very same coin once, what is the probability of getting a tails? That also gives you 0.5. Now, can you see that if we add these two probabilities, probability of A plus probability of B, we will get a 1. I'm hoping it's clear for everyone. So if you add those two probabilities together, you must get a 1. Those are complementary events. I'm getting thumbs up. Okay, there's a question from Wandile. Let me think of another example. Maybe let's look at the die. So with the die, getting even numbers, we're going to get 2, 4, and 6. Odd numbers, we're going to get 1, 3, and 5. Now, what is the probability of getting an even number on our die? Anyone? The probability of getting an even number, it's 3 over 6. And 3 over 6 is the same as what? 0 over 5, 0, 0.5, not 0 over 5, but 0, 0.5. Now, what is the probability of getting an odd number? It's also 3 over 6, and this simplifies to 0 0.5. Now, we're going to check the probability of an even number plus what? The probability of an odd number. What does this give us? The probability of even is 0, 0.5. The probability of an odd number is also 0 0.5. Now, this will give us 1. Now that it gives us 1, what can we conclude about the probability of even and odd? What can we say about these things? They are complementary. Complementary events with an E. Hope it makes sense. Perfect. I'm getting a thumbs up. Okay. Let's look at this example together. I'm hoping that you guys are with me. I'm going to take it a little bit slowly today so that you guys at least are following each and every step. If I can at least do all the explanations for you, I'll be quite happy. Now, while we're on the complementary event, remember I explained that there are some must give you 1, and also, right, remember something, let me just erase this. I'm going to need to write more. The events have to be mutually exclusive. For them to be what? For them to be complementary. That's very important. Now, let's look at it mathematically. We said this is the probability of even plus the probability of odd, and it gives us 1. We can play around with this. The probability of an even number would be what? Would be 1 minus the probability of an odd number. Okay, now let's look at it using not. So the probability of what? Of not, of not even would be equal to 1 minus the probability of what? Of even. I want us to understand this. Remember, we have even and odd, only these two. When I'm saying not even, this not even means I'm canceling out the even. What am I actually looking for? When I say probability of not even, what I'm trying to say is the probability of O. I'm hoping it's clear for everyone. Thumbs up. Perfect. Now, how can we write not E mathematically? It's going to be probability of E prime is equal to 1 minus probability of E. I'm hoping it's clear for everyone. Great stuff. Now let's quickly move on. Here's just an example that I would like us to look at together, right? A fair die is rolled, right? What is the probability of getting a multiple of 3? This is a question that I'm asking you guys. If you have an answer for me, you're more than welcome to post it in the chat. So a fair die is rolled once. What is the probability of getting a multiple of 3? Okay, I'm already getting answers in the chat. Thank you so much, guys. I'll give you 20 seconds to quickly think about it. There are already answers in the chat. Okay, so we're getting 2 over 6, which simplifies to 1 over 3. Okay, now how did we even get there? So the probability of a 3 or a 6 is equal to what? Is equal to the probability of a 3 plus the probability of a 6 minus what? Minus the probability of 3 and 6. That's the formula that we used, the addition rule. Now let's check. What's the probability of that? That'll be 1 over 6. Because that's a multiple of 3. It's only 3 and 6. Now the probability of 6 is just what? Now, can we get 6 and 3 at the same time? We cannot. And then this gives us what? 2 over 6, which is 1 over 3. Okay, remember, we are not talking about factors, we are talking about multiples. So when we're saying multiples of 3, we're going to start with that number. We're not saying factors, we're saying multiples. So if I say multiples of 4, I mean start at 4 and keep adding 4. So 4, 8, 12. If I say multiples of 3, I mean 3, 6, 9, 12. You just keep adding that number. That's why we're not including 1. Factors and multiples are two different things. I'm hoping it's clear for everyone. Getting a thumbs up. Perfect. Okay, now we're quickly going to move on. There is still a lot that we need to cover. I want us to look at what? Dependent and independent events. Now, I'm going to start with independent first. The word says it all. Independent. Okay. So independent events would be when one outcome of an event does not affect the other one. What do I even mean there? So, coin toss and rolling of a die. Now, us obtaining a heads here, does it affect any outcome that we're going to get when we roll the die? Okay, You guys asking me to repeat the statement of independent. So independent events, right? So events are said to be independent if one outcome of an event does not affect the probability of another event happening. The outcome of one event does not affect the probability of another event occurring. Is it clear for everyone? Okay, let me just help Yolisa to unmute. Yolisa has a question. Yolisa, you can unmute yourself and ask your question so we can try to address it quickly.
Oh no, so sorry, I don't have a question.
Okay, all right, perfect, no problem. Okay, I've repeated the statement of independent. I think we're all on the same page. Okay. Now, obviously for dependent, it means that what? It means that one outcome affects the other. I don't know if we're all together there. Maybe an example of this could be picking a, maybe you've there was a competition at a certain place, and then they are giving 5 different cars to 5 different people, right? Now, those 5 different cars, obviously they're not the same, and the probability of saying, maybe let's say we have a Mercedes, we have a BMW, we have a Toyota. Okay, let's say we have 2 Toyotas, and we have an Audi. Now, what would be the probability of getting a BMW? The probability of getting a BMW would be 1 out of 1, 2, 3, 4, 5. So we can say it's 1 out of 5. Now, this car is now out. The next person is told to come and pick. So remember that this is 0, 2. What is now the probability of getting a Toyota? That will be what? 2 over 4, because these are just straight, even if they are different, but the same brand. This is 2 out of 4, and this gives you 0.5. Now, this is only because we took out the BMW. If this BMW was not taken out, the probability of getting a Toyota would be the same. Not as the BMW, but it would be the same every single time. Not the same because we have 2 Toyotas. Those are dependent. One outcome needs to affect the next outcome. Hoping it's clear. Okay, let's address the Q&A. Okay. So what did I say about the independent? So I said the independent events, right? They do not affect each other. Right? I give an example of a coin toss and rolling a die. So we'll toss the coin first. We get either a heads or a tails. Now, does us obtaining a heads or a tails affect the outcome that we're going to get on the die? No, it doesn't. It doesn't at all. We toss that coin, gonna get a heads. Roll that die, the probability of getting an even number would still be 3 out of 6, no matter what the heads was. That's for independent events. Now for dependent events, would be this case here, where we don't replace. That's the easiest way to think of dependent events. The first outcome needs to affect the second outcome. So I said, firstly, the first person comes and picks a BMW. The probability of getting a BMW is 0.2. The probability of getting a Toyota is now 0.5, given that the BMW is out. But if the BMW was replaced, right? If, yeah, you came and you picked a BMW and then they replace it with another BMW, the probability of getting a Toyota would now be 2/5. Can you see that taking out this BMW affects the probability of getting a Toyota? Okay. And then the dependent, yeah, that's what I was doing now. The independent is coin toss and rolling die. Dependent is this. Okay, let's quickly move on. Now, there's a product rule for independent events. So P, A, and B would be equal to what? Would be equal to the probability of A times the probability of B. This is independent. Now, dependent. The probability of A and B can be written as what? The probability of A times the probability of B, given that A has occurred. Remember that this means the probability of B happening given that A has occurred. And we did look into this in detail. Now let's think of that example when I said we are tossing a coin and what? And rolling a die. What could be the probability of getting a 6 and a head? What could be that probability? I want us to think about it for a second. I'll give you guys 30 seconds if you're working it out. If you have an answer for me, you're more than welcome to use the chat. To the guys who are watching live on Zoom, if you'd like to be a part of this, to the guys who are watching live on TikTok, if you'd like to be a part of the Zoom audience, you're more than welcome to check the chat, click on the link that they send in the chat and join us live in Zoom so that you can ask some of the questions that you have for us. So we are trying to get the probability of getting a 6 and a heads. So we toss a coin, we roll a die, the probability of getting a 6 and a heads. Okay, let's quickly look at it. Now, we know that the probability of getting a 6 is simply what? 1/6. There's only one way we can see a 6 out of a total of 6 possible outcomes. Now, the probability of getting a head is going to be what? 1/2. Now, the probability of 6 and heads. Remember what we said. They are independent. Okay, because they're independent, we can simply say this is the probability of A multiplied by the probability of B. The probability of A is how much? The first one is 1 over 6. The probability of B is what? 1 over 2. And this simplifies to 1 over 12. That's how everyone is getting the 1 over 12. Now, if they say to you, prove that events are independent, this is what you have to show. You have to show that the probability of A and B is equal to the probability of A multiplied by the probability of B. If you ever get such a question. I'm hoping it's clear to everyone. Perfect. I'm getting the thumbs up. Now, what's next? Venn diagrams. Now, when we're talking about Venn diagrams, these are diagrams that are represented with a rectangle normally and circles inside. Now, these represent the two outcomes that we're trying to observe, and this represents everything that is outside the two outcomes. Sometimes you're going to have what? You are going to have events that overlap. And this overlap here is the and part that we were talking about. Okay, now let's make it practical. I want to make use of a three-way Venn diagram. So a three-way Venn diagram, maybe it looks something like this. I'm going to just give it some, okay, let's make it a little bit bigger so that we can clearly see. Okay, so let's say this is biology, this is accounting, and maybe this can be physical science. Why not? Now, can you see that there's an intersection somewhere of the three circles? There's a place where all the three circles touch, come together, and it's this one. Right, what does this mean? It means that whoever is found in here takes what? Takes three subjects. So I'll represent it here. So in green, you're taking what? All the three subjects. Now, here, what are you taking? Anyone? In blue, the blue that I just highlighted here, you're taking two subjects being accounting and bio. I'm hoping it's clear to everyone. Okay, I'm not going to do the rest because it looks quite easy. I don't know if everyone is covered there before we move on. Perfect. I'm getting a thumbs up. That's what a Venn diagram looks like. We are definitely going to look at these in more detail together with tree diagrams. Okay, so I want us to jump to tree diagrams and then contingency tables as well. Then we're going to do some past paper questions on those things. A tree diagram would look something like this. Maybe that's not a good color. Let's go to black. Tree diagram. Now, if it looks something like this, let's say we are rolling a die with 4 sides. So we've managed to, it's not a cube now, we've managed to make a shape with 4 sides. We have 1, 2, 3, and 4. Those are the sides that we have. What is the probability of getting a 1? That'll be 0.25. What is the probability of getting a 2? That'll also be 0.25. Probability of getting a 3, 0.25. And lastly, the 4 will also be 0.25. It's a four-sided die being rolled. After rolling this die, we then toss a coin. Okay, so this is what we can do. So here, we're going to have what? A heads or a tails. We roll that die first. Remember, let me just write the numbers here. Number 1, number 2, number 3, and number 4. If you get a 2, you can also get a heads or a tails. Same thing with the 3. You can either get a heads or a tails. With the 4 as well, a heads or a tails. Now they can ask you a question like this. What is the probability of what? Of getting a 3 and a head? Right. Let's give some values here. What is the probability of getting a head after a coin toss? 0.5, 0.5. All of them. Now here's the question. What is the probability of a 3 and a head? We're getting 1/8 from a lot of people. Thank you so much for attempting. Please remember to attempt these questions with us so that you can see where you are going wrong, or you can ask questions if you're not getting the same answers as us. Now, how are we getting the 1/8? I'm also getting 1/8 on my side. How are we getting that 1/8? What is the probability of getting a 3? It's going to be what? 0.25. What is the probability of getting a 8? It's going to be what? 0.5. And that's how you get the 1/8 or 0.125. Now, let's make it a little bit more complex. Probability of what? Of an even number. What is that probability? Okay, we're getting 1 over 2, we're getting 2 over 4. I'll give you 15 more seconds to just attempt it. Okay, let's quickly look at it. So the probability of getting an even number will be what? Will be the 0.25 multiplied by what? Multiplied by 0.5. So it's, let me just try to shade it here, or let me just highlight. So it can be that, or it can be 0.25 multiplied by what? Multiplied by 0.5. This is for the tails. This was for the heads. This is for the tails. Now, it doesn't only end with the 2. The other even number would be the 4. Right? And this will be what? 0.25 times 0.5, 0.25 times 0.5. Heads, tails, heads, tails. And then we just add all of these up. And this should give you 0.5. Okay, let's address the question in the chat. Why do you multiply by 0.5, but you say probability of getting an even number? Okay, that is a great question. Let's just address it. Now, remember, the even number is either what? The even number is either it's the 2 or the 4. Now, when you get a 2, you can get what? You can get heads, and you can also get tails. When you get a 4, you can also get a head or a tails. Now, we must address all of these. Getting a head is 0.5. Getting a tails is also 0.5. These ones as well. These are the even numbers. 2 multiplied by 0.5 for the heads, plus 2 multiplied by 0.5 for the tails. We're going to have to do the same thing for the 4. 4 multiplied by 0.5 for the heads, and 4 multiplied by 0.5 for the tails. And then you have to add everything up. So this is for 2, and this is for the 4. I'm hoping it's clear now. Okay. Now contingency tables. Okay, so contingency table would look like a table, definitely. Let me just try to replicate one real quick. Okay, something like this. Okay, but let's say we have male here, and then we have female. Here on the right hand side, we're going to have a total. Now this will be condition 1, and this will be condition 2, and then this will also be your totals. That's what a contingency table looks like. Okay, now let's try to address some of those questions together. Because I know some people are already getting bored. They want to attempt the questions, but we had to explain them thoroughly before we address problems. Okay, so here's a question. A survey was conducted among 100 boys and 60 girls to determine how many of them watched TV in the period during which examinations were written. Their responses are shown in the partially completed table below. Calculate the values of A and B. This is what you need to expect in your exam if they ever ask you a contingency table. Now, we need to remember something, that these are the totals, right? Since those are the totals, I can simply say that A plus 12 must give me how much? It must give me 32. Okay, which means that A is simply going to be what? 32 minus 12. And A is simply 20. If I make a silly mistake, please do stop me, but I'll try to pay attention and be careful to avoid any silly mistakes. Now, in the same manner, I want you guys to try and find B for me. Just by doing this, you already have yourself 1 mark here for A. Okay, thank you so much for the quick answers that are coming in the chat. B is simply 128. Why? We just added the 80 and the 48. Now, another thing, when you add B and this 32, you must get the 160. Otherwise, you've made a mistake somewhere. Because it is the total in that direction as well. Okay, now here's the next question. Are the events being male and did not watch TV during examinations mutually exclusive? Okay, the statement again, a survey was conducted among 100 boys and 60 girls to determine how many of them watched TV in the period during which examinations were written. That's very bad. Their responses are shown in the partially completed table below. Are the events being male and did not watch TV during examinations mutually exclusive? Give a reason for your answer. If you have an answer for me, please do type it in the chat. I'm getting no, but why is it a no? Yes, absolutely. So we will say no. Why we say no? The probability of male and did not watch TV is equal to what? Let me just clear this up. So let's just write the value of A. So probability of male and what? And I'll say not watching TV just for short, not TV. Just say OWTV so that it's clear when you guys are looking at these, not watching TV. And not watching TV must be equal to how much? It must be equal to 20 over what? Over the total, which is 160. The total is 160. Not only the total for male, but the overall total, the sample space. And this is not equal to 0. Okay. Just like that, you've scored another 2 marks. Let's look at 11.3.1. If a learner who participated in this survey is chosen at random, What is the probability that the learner watched TV in the period during which the examinations were written? This learner, chosen at random, did watch TV during in the period during which the exams were written. So I'm going to write it this way. So the probability of watching TV is going to be equal to how much? How many people watched TV? Scroll back up. Okay, maybe let me do it this way here so that we can still see this is that one there. And then I will do that one over there. How many, what's the total number of people that watch TV? It's going to be how much? 128, because it's what we found for B. Out of a total of 160. And I think this does simplify. It should simplify to 4 over 5. Please correct me if I'm wrong. That's just calculator work. Yeah, 4 over 5. Great stuff. Now, the next question. This learner is not male. This is very important. Not male and what? Did not watch TV. Okay, if this learner is not male, this learner has to be female. Now, they did not watch TV. So how do we go about that? We have to look at the female that did not watch TV. And where's that? So there is female and there is did not watch TV. So they meet here. And that is how much? That is simply 12 out of 160, the total. This can simplify to what? To 3 over 40. I'm hoping it's clear for everyone. Great stuff. I'm getting a thumbs up. Okay. Now let's pay attention to this one here. Now this is your counting rules. Okay. It's saying the digits 1 to 7 are used to create a 4-digit code. Okay. To enter a locked room. How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000? Okay, I need you to pay extra attention here. We're saying 4 digits means that I'm going to have these open spots 1, 2, 3, 4 for the digits. Now, we want a number that is bigger than 5,000. Now, how many different codes are possible? Okay, I'm getting fractions. I'm thinking those are for the different, these are for the previous answer, because you either have a full code or you don't have a code at all. It must be a natural number. Now, let's start here. We want it to be what? We want it to be an even number. For us to get an even number, remember we can pick from 1, 2, 3, 4, 5, 6, and 7 only. How many options, remember, want to create an even number. How many options do we have for this particular spot? Anyone in the chat? Just how many options can we put? How many different numbers can we put in this position? Let me say this is position 1, this is position 2, 3, and 4. In position number 4, how many different numbers can I put for me to get an even number? Okay, I'm getting a 3 and I'm getting a 4. According to me, it's a 3. Why is it a 3? Because I can either have a 2, a 4, or a 6. If my number ends in 1, 3, 5, or 7, it is not even. Are we together? That's why we're going to say what? We're going to say we have the options 2, 4, or 6. Hoping it's clear for everyone, okay? Getting it makes sense. If you are not winning, please do talk to me so I can see how I can assist you. Now, it must be bigger than 5,000, meaning that, so let me write it in red here. I need a 5. So I need a 5 for me to have bigger than 5,000. Now, how many numbers can I put here? If that's the case, how many numbers can I put here? In position number 1. We can put 3 numbers. Why 3 numbers? We can either put a 5, we can put a 6, or we can put a 7. Yes, if you're saying 3, you're with me. Okay? Now, let's check. How many options do I have here? Okay, there is an interesting question in the Q&A. So isn't it that when we put 6 at first position, we can't put it last? Yeah, very correct there. Okay, now it's interesting. The number must be greater than 5,000. We can't put 7 there because it's not even. So Trevor, I don't know where you're saying we cannot put a 7. So we can't put a 7 only at the end, but we can put it at the beginning. So something like this. 72 is an even number because of the 2. 74 is an even number. 76 is an even number because of the 4 and the 6. Okay, so let's address this question as well. So what if I chose 6 because 6 is bigger than 5? Yes, but that's not the only option, right? Remember that this is 5,000, right? This is equal to the 5,000 that they gave us. But once we put a number here, so maybe let's say 5100, that is an option that is bigger than the 5,000. So we want all the possible combinations, right? How many different codes are possible? So it must be all of them. So if you pick 6, you're omitting some of the possible combinations. Okay, I hope it's clear. Let's quickly finish this question. Let's wrap it up. Now, here's an interesting question in the chat, right? Anonymous said, isn't it that we, when we put 6 at first position, we can't put it last? That's correct. Why? Because they said may not be repeated. Okay. So it must be bigger than 6,000. I'll say 5, 6, and 7 here. Then if I say 5, 6, and 7 there, then it means I have 2 options for that part. I hope we were all together there. Now, let's look at position number 2. How many possible numbers can we put in position number 2? Okay, I'm getting an answer from Lisedi. Lisedi is saying it has to be 3. Okay, I'll start with you, Lisedi. Why are you saying it's 3? Okay, please give a reason to your answer as well. As we've already used the numbers 5. Okay. All right. Now let's do this so that we can finish up this question quickly. Let's break them down into cases, right? So I'll say case 1. What do we have? The last digit is 2. So please bear with me. Last digit is 2. Now, if the last digit is 2, right? This is for the even number. It means that the available digits are going to be what? 1, 3, 4, 5, 6, and 7, because 2 is at the far end. Now, we still need them to be greater than 5,000. So if we want them to be greater than 5,000, we can only use what? 5, 6, or 7. So this means we either have what? We have last digit being 2, and then we can only pick 5, 6, and 7. Those are the 3 options that we can pick. Right. Now we need to check. The second digit must be what? Second digit, how many options do we have? We had 7 numbers. We picked 2. So we have 5 left. And then how many do we have left after the 5? It's going to be 4. Remember, this is us picking a 2. So what we're doing is we're actually, if we are picking 2 here, it's ones. We can only pick 2 ones. Pick 2 ones. That's what we can do. That's why I'm saying this is 3 times 5 times 4 times 1. This is where the 1 is coming from. Okay, and it means that what do we have now? We have 60. Okay, we're not done. Now, case 2, the last digit is 4. Let's do this. So case 2, last digit equals to 4. Now, if we take out the 4, what are we left with? 1, 2, 3, 5, 6, and 7. Now, the first digit needs to be what? It needs to be either 5, 6, or 7. So I'll say 3. Second digit, how many numbers can we pick from? We pick from the remaining 5 because the last one One digit is a 4. And then how many are we left with here? We're left with 4 digits. Now, we multiply 3 times 5 times 4 times 1. And this gives you how much as well? This gives you 60. Now, the last case is when we have a what? When we have a 6 at the end. Once. We can only pick a 6 once, remember. So here we have not 5 numbers, but 3 numbers to pick from. Sorry about that. 3 numbers to pick from. And then since we took out 2 numbers, we're left with 5, and then we're also left with a 4. And then we just multiply, but this, remember, is a 1. And that gives us the total when we multiply. Now it means that the final answer has to be a what? Sorry, I think I made a mistake. So the last case is a 6. I don't have 3 here. I only have 2. It's a silly mistake. It's a silly, silly mistake. If you've spotted it, thank you. It has to be 160 because this gives you a 40. I'm hoping it's clear to everyone. And those are some counting rules. Okay. Let's briefly look at it again, quickly, to the guys who are lost. There's a very simple question that I need you guys to be able to do. Okay, so I want to start it here. They said the code must be even, and we've identified the even numbers, okay? Now, it's either we end with a 2, or we end with a 4, or we end with a 6 for us to have even. Are we clear? That's the first thing that we're agreeing on. Now, if we are ending with a 2, let's start with a 2. Let's forget about the other ones for now. If we are ending with a 2, one, two, three, 4. How many 2s do we have to put in this position? Pay careful attention. How many 2s do we have to put in this position here? It's only 1. Because we want this to end with a 2. Now, we want this to be, so now the 2 is out. Done. Okay? We're left with 6 numbers. Now we want this to be bigger than 5,000, meaning that we either need a 5, a 6, or a 7. So how many numbers can I put here? Anyone? I can put 3 numbers, 5, 6, and 7. Now, it means that one number is out because I took out a 5, a 6, or a 7. I took out one number. Okay, so if one number is out, how many numbers am I left with? I'm left with 5. And then after this, how many numbers am I left with? A 4. Now, we're not putting a 2 here because we're saying how many 2s do we have? There's only one 2. Then we simply say this is 3 times 5 times 4 times 1, which gives us 60. Hope it's clear for everyone there. Now, let's change it. Still the same code, except now we want 4 at the end. How many 4s do we have? How many 4s do we have? We only have 1 4. Let's take that 1 4 and put it here. It's only 1 4. Now, how many numbers can I put here for this to be bigger than 5,000? How many numbers can I put in the first position? 3. It's either a 5, a 6, or a 7. Those are the numbers that I can put. Now that the 4 is out and another number, either a 5, a 6, or a 7 is out, how many numbers am I left with? Because we cannot repeat. 5. Now that we've taken out another number, how many numbers are we then left with? 4. Then it's just a matter of multiplication. Now check. This is going to give you how much? It's going to give you 60 as well. Now, same code, 4 digits. We put a 6 at the end. How many 6s can we pick? How many 6s are at our disposal? Only 1 6 is at our disposal. So we take that 6 and we put it here. Now the 6 is no longer there. Okay, now that the 6 is out, we still want the number to be bigger than 5,000. How many numbers can I put in position number 1? Please think about it again. The 6 is out. How many numbers can I put in position number 1? But the 6 is out. Remember, guys, the 6 is out. That's why it's not 3. If the 6 is out, I'm left with a 5 or a 7. Those are 2 numbers. Now that 2 numbers are out, how many numbers am I left with? With 5. And then after taking out a number, how many numbers am I left with? I'm left with 4. Now you multiply this, and this gives you how much? This gives you 40. Now the total is just 160. 60, 60, 120 plus 40 gives you 160. Perfect. I'm glad we're all together there. Now let's quickly move on to this question here. Getting a thumbs up. Okay. So I want us to look at A. They're saying A and B are 2 events in a sample space. Right. The probability of A is equal to 0.3 and the probability of not B is equal to 0.8. Now they say determine the probability of A and B if A and B are what? Are independent events. A and B are independent events. We want to determine what? The probability of A and B. Now we have discussed these thoroughly. So I'm going to give you guys just 45 seconds to quickly try to get an answer for A1. Then we're going to discuss it together. We're getting 0.24. Thank you so much for attempting. We're going to check it together shortly. Give you 20 more seconds. And remember, guys, to invite your friends. I know we're left with 30 minutes, but there are still a lot of questions for us to tackle. If they join us now, they'll still greatly benefit from this session. I know probability is quite a tough one, and it does take quite a few marks. You cannot afford to lose them, so please do invite them to come to the session. Okay, getting different answers, 0.24 and a 0.06. All right, let's check which one is correct. So firstly, I want to find the probability of B. What is the probability of B? The probability of B would be what? Let me start it here. They said that they are independent. If events are independent, the probability of A plus the probability of B, the sum is going to give me how much? The sum is going to give me 1. Now it means that the probability of B is simply what? 1 minus the probability of A, which means that the probability of B will be 1 minus 0.3. Oh, sorry, my mistake, sorry. The probability of not B, I'm making a silly mistake, let me correct myself. They said if it's not B, anything that's not B is 0.8. So I have to say 1 minus 0.8. B prime, because it's not B. There are other things in the sample space as well that I didn't account for. All right, now it means that the probability of B is how much? 0.2. Now, what does it mean? The probability of A and B is simply going to be how much? 0.3 for A, and B is now 0.2. And that should give you 0.06. I'm hoping it's clear for everyone. Perfect, I'm getting a thumbs up. Now, number 2, determine pay A or B if A and B are mutually exclusive events. I gave you definitions for mutually exclusive events. That's why we spend so much time looking at the definitions and addressing any concerns with those definitions or phrases that they use and terms that they can use. Okay, we're getting a 0.5. Okay, there's a 0 as well. Okay, I'll give you 15 more seconds to quickly attempt it before we look at it together. Okay, perfect. Let's quickly look at this. Now, the probability of A or B, because these are mutually exclusive, A or B will simply be what? The probability of A plus the probability of B. And this must simply be 0.3, that's given. And this is what we calculated, 0.2. And this will then give you 0.5. Now, if you've made a mistake here in the exam, and you take the very same value that you made a mistake with and plugged it in here, right? They will give you those CA marks. So please do not leave it out. Take that value and substitute here. Okay, now let's quickly move on. We're going to skip some questions so that at least we have done a variety of questions. Now they're saying, given the digits 3, 4, 5, 6, 7, 8, and 9, calculate how many unique is very important, 5-digit codes that can be formed using the digits above if the digits may be repeated. Okay, that's how I need you guys to go about it. I'll let you guys quickly attempt 11.1.1. If you have an answer for me, you're more than welcome to post it in the Q&A or in the chat. Remember something, for your time, you must always check the mark allocation, right? So that you don't run out of time. If a question says 2 marks, it means that you cannot spend any more than 2 minutes on that particular problem. Otherwise, you are going to end up leaving some questions unanswered. Here, I might not give you the full 2 minutes just because we don't have enough time. Okay, we're getting a 7, we're getting 16807. Okay, 10 seconds, and then we have to mark it together. Okay, let's quickly check. They said it's a 5-digit code, right? And they said they can be repeated. If we can repeat digits, right? So in position number 1, how many numbers can I pick from? 7. I can repeat the numbers, remember. In position 2, I can also pick 7. In all those positions, I have 7 numbers to pick from. Right? This simply becomes what? 7 to the power of 1, 2, 3, 4, 5. On your calculator, this is going to give you 16,807. Now, the digits may not be repeated. Let's quickly look at that one in 40 seconds. If you have an answer, please do share it in the chat or the Q&A. Okay, we're getting 2520. Okay, why is it 2520? So 5 options still: 7, 6, 5, 4, and a 3. And that you just multiply, and that will give you the 2520. I'm seeing a surprised emoji. I don't know if that's a surprise because you didn't know it's that easy, or if it's confusing, but I hope it makes sense. Okay, I'm getting thumbs up and a heart. I think everyone is with me. Perfect. Now, let's move on to 12.1. Like I said, we are going to skip some of them. If we have enough time, we will come back to some of these questions. But I want to do 12.1 and 12.2 quickly. Right, 12.1, you guys will be able to do. What are they saying here? Given that P of A is equal to 0.45, P of B is equal to Y, and P of A or B is equal to 0.74. Determine the value or values of Y if A and B are mutually exclusive. They're mutually exclusive. I'll give you guys a minute for that one. Yes, these lessons are recorded and they will be posted on our YouTube. It should be up by the latest tomorrow evening, together with the lecture notes, or the lesson notes rather. They will be posted. Do check our website. The link to our website will be posted in the Zoom chat and also on TikTok if you're watching live from TikTok. Remember to like our content as well, guys. Please give us the motivation to keep bringing this to you guys free of charge. Don't only watch, but like. It doesn't cost you a cent to like our videos. Okay, I'm getting 0, 0.29, 0, 0.3, and a 0. Okay, perfect. Let's quickly check. Now, the probability of A or B is equal to how much? Is equal to the probability of A plus the probability of B. Now, this is given to be 0, 0.74 in value, and the probability of A is given to be 0, 0.45. And the probability of B is a variable, which is Y. And then Y is going to be how much? 0, 0.74 minus 0, 0.45, and that gives you 0, 0.29. Right, remember they usually say the first few pages, you are going to have some exam rules. They usually say correct it to decimal places, unless otherwise stated. Right? So do not convert this to a 3, leave it as 0, 0.29. Are we together there? Okay, let's quickly move on. I want us to now look at this one. Now they're saying machine A and machine B are two different coin pressing machines that operate at the same time. The probability that machine A only presses a 5 Rand coin is X. And the probability that machine B only presses a 5 Rand coin is 0, 0.3. The probability that both the machines press R5 coins at the same time is 0, 0.1. Now, 11.1.1. If A and B are independent events, determine the values of X and Y. Very important. Independent events, we need to determine the values of X and Y. Now remember something, I gave you rules about independent events. That's why we spend so much time looking at the theory part of this. So finance and probability are the sections that are sort of heavy on theory as well, where you need to understand the terminology quite well. I'll give you guys a minute to quickly attempt this, then I will help you guys with it if you're struggling. But please do attempt it. Okay, we got X is equal to 0, 0.7. Thanks to Lucinda. You can attempt to get the value of Y. Okay, we are getting different answers. Okay, 25 more seconds, and then I do it for you guys. And guys, there's a link for giving us a review that's posted in the chat as well. If you feel like we've given you 5-star service, please give us a 5-star. Those 5 stars are really, really appreciated. They help us continue giving you these kind of sessions free of charge, right? If you feel like we didn't give you 5-star service, tomorrow, I promise you, we will make it up. We are doing physical sciences tomorrow, so please join us then, and we will definitely give you a 5-star service so that you can go back and give us that 5-star review. Right. And also tell us what was your highlight of these sessions. Right. So when you leave a review, type a nice message as well. You can say that the tutors are patient, they are thorough, something like that. Okay. Now, the first thing that I want to do is, because these two events are independent, right? I know what? That the probability of A multiplied by the probability of B, so A and B will give me what? Will give me 0.1. So I can say that A is X plus what? A is X plus 0.1. Now, if I multiply it with B is going to be how much? 0.4. Why is it 0.4? Because we've added these two, remember? This must be equal to how much? This must be equal to 0.1. Then let's solve for X. X plus 0.1 is equal to how much? 0.25. Now, X is going to be 0.15. Hope it makes sense to everyone. If it makes sense, please give me a thumbs up. Perfect. We're all winning. Now, we need to remember something, that the probability of a sample space is equal to 1. The probability of a sample space is equal to 1, meaning that X plus what? Plus 0.1 plus 0.3 plus Y is equal to what? Is equal to 1. So what I did, okay, going back, I simply said the probability of A and B must be equal to what? Must be equal to their intersection, which is 0.1. Now, because they're independent, what do? We simply say P of A multiplied by P of B. This is equal to 0.1. And then I substituted. A is this whole circle here. That is A. That's why it's X plus 0.1. And then B is this whole circle here. That is 0.4. And then I replaced. So divide both sides by 0.4. These two cancel each other out. The brackets fall away. You have X plus 0.1 is equal to 0.25. You take the 0.1 over to the other side, and then X is 0.15. Now for this part, this is the sample space. The probability of an entire sample space will always give you 1, right? Coin toss, you have heads, you have tails. This gives you 0.5. This also gives you 0.5. Rolling a fair six-sided die, you get 1 over 6 for the 1, get 1 over 6 for the 2, 1 over 6 for the 3, 1 over 6 for the 4, 1 over 6 for the 5, and 1 over 6 for the 6. The totals here, you're going to get 1. The totals here, you're also going to get 1. So that is the probability of all possible outcomes. It will always give you 1. That's what I'm doing here. Now, we have found X. It's 0.15 plus 0.1 plus 0.3 plus Y is equal to 1. And it's a matter of solving for Y. Take everything over to the right-hand side. Leave the Y on the left. You are going to get 0.45. Hoping it's clear for everyone. Perfect. I'm getting a thumbs up. All right, cool stuff. Now let's look at this tree diagram question here. Okay, so they're saying Wilson takes a driver's test. The probability that he will succeed on his first attempt is 3/7. For each attempt that he redoes the test, the probability of passing increases to 3/5. What is the probability that Wilson will succeed after 2 attempts? Okay, what do we need here? We need a tree diagram to attempt this question. Okay, now for us to be able to attempt this, we're going to have the options passing and failing. So I'll say this is failing and this is passing. And remember, for you guys, failure is not an option. You cannot afford to fail these 2 subjects, being maths and physical sciences. Now, back to the question. So if the probability that he will succeed on his first attempt is 3/7, we know that the probability that he will fail is going to be how much? 4/7. Okay. Now, if he fails and he redoes it, we're going to have a branch there. Okay. They said for each attempt that he redoes the test, the probability of passing increases to 3/5. So if this is passing, it's going to be what? 3/5. If this is 3/5, what's left? 2/5, because these 2 need to add up to 1. Okay, this is failure, remember? Now, they said 2 attempts. He will succeed after 2 attempts. So this is the first, second, right? So we need him to succeed where? That he will succeed here. So this will be failure and this will be pass. Now, this is still how much? 3/5. Okay, now this is the branch that we need to follow. Failure, failure, followed by a pass. Hope we're all together here. So after 2 attempts, not on the second attempt. So he does this, he fails. He does this, he fails. Then after these 2, he then passes. The terminology is very important there. The English is very important. So on the third 2 attempts, on the third attempt. That's what they're trying to say. And then what do? We follow the branch. Is it clear for everyone there? That's how I go about it. That's a tree diagram. Failure, failure, and then followed by that pass. Okay. A thumbs up if you understand, please. Perfect. Means that we're all together. Great stuff. So what do we have to do here? We have to say 4/7 multiplied by 3/5 multiplied by what? By 3/7. And then just like that, we get our answer. The time is now a few seconds before 8 o'clock. I think we can all wrap up here for tonight. Tomorrow we will be doing physical sciences. Please make sure that you do attend those sessions. I find them very, very helpful. Remember, guys, we need those reviews. Please do give us a 5-star review if you feel like you have gotten or received 5-star service. If not, do join us tomorrow. We will make it up to you. We will definitely give you 5-star service. Remember that these reviews help us to keep bringing you these sessions. Even in the future, we are going to have preparation for trials. So if you keep giving us those 5-star reviews, you definitely will be seeing us to help you with trials as well. Tomorrow, they will be doing physical sciences. I'm not too sure if it's physics or if it's chem, but please do check. Okay, there we go. So tomorrow is electric circuits from 3 until 5. Please make sure that you share the if make sure that you share the link with your friends. If you're on school WhatsApp groups, do share it with them as well so that they can join. If you have friends or family that are in different parts of South Africa and you know they need these services, please share with them. Okay. So trials are just trial examinations or prelims. All right, guys. I think we can all end here for today. This was our very last session. We'll see you again for the trials. It's really been a pleasure having you guys. Remember to please follow us and like our content. Right, remember on TikTok we are at the Learning Space ZA. On Instagram we are the Learning Space ZA. On YouTube we are the Learning Space ZA. There is a link to our WhatsApp channel as well in case you need to get in touch with us. Please make sure that you copy the link and you save it on your devices. Yeah, like I said, my name is Tepangati, and it's been a pleasure to have you guys. I think we can all end here for today. Have yourselves a lovely evening.